learning has advanced state-of-the-art in many vision tasks and computer vision. Most of the deep learning algorithms are using batch normalization because batch normalization can improve training by accelerating training and also help the model to converge to better solution. There are two things that the batch normalization does. First one is a smoothing effect, and second one is avoiding elimination singularity. So let's see what is a smoothing effect. So this figure shows that batch normalization makes the optimization landscape smoother while preserving all of the minima of the normal landscape. In other words, batch normalization reparameterizes the underlying optimization problem, making the training faster and easier. What about singularity in deep neural network? There is a paper called Skip Connections, Eliminate Singularities. And in figure 1 of that paper, the author showed different kinds of singularity that can happen during training a network. One of these singularities is elimination singularity. That means one of the weight converges to 0 and eliminate from propagating the weights through the network. The second kind of singularity is overlap singularity, that two different weights exist in the network, but they are overlapping to each other, so it makes outgoing weight non-identifiable. Another kind of singularity is linear dependence, that one of the weights is a linear combination of two other weights. So that's kind of redundancy in the network, and it's called singularity again. So batch normalization, by forcing each neuron to have zero mean and unit variance, keeps network at far distance from elimination singularity caused by nonlinear activation function. So of course, using batch normalization is good, but sometimes it's not feasible to use a large number of samples in one batch, maybe because of limitation in the GPU memory that we have, especially in vision task and computer vision. So what we can do in these conditions that we cannot use large number of samples in one batch, but still we want to use and take advantage of the batch normalization process. So the paper called Micro Batch Training with Batch-Channel Normalization and Weight Standardization bring a techniques that we can use batch-channel normalization and weight standardization instead of using large number of sample in one batch, and even outperform sometimes when we use just batch normalization. In this figure, figure 1, they're showing that if we use group normalization, batch normalization, or sometimes combination of them with weight standardization, they are not still good as when we combine Batch-Channel Normalization and weight standardization. So let's jump to this. What is group normalization, layer normalization, stuff like that. So there is a figure here that can help us to understand that. In instance normalization, what we do is if we have C number of channels and N number of samples, and each input has dimension of height and width, for example, these are images. So if you want to do batch normalization, it means that for each special channel, we apply normalization on all samples. So for example, if I have 10 different images, I apply normalization on only red channels, then on green, and then on blue channels. So in this case, I'm applying batch normalization. In layer normalization, on the other hand, we don't care about different samples, and we only take care of the one sample that we have, and we apply normalization on only one sample, respective to their channels. So in this case, if we have R and G and B, we do the normalization on the whole channels. In instance normalization, we don't care about different channels and number of samples, and we only apply normalization on only one of the channels on one of the images. The group normalization is taking advantage of instance normalization and also the layer normalization, and it grouping some of the channels and taking the normalization of that group instead of taking the normalization of the whole number of channels or only one instance. Weight standardization, on the other hand, is something that is applied on weights, not data. So for example, if you're applying convolutional neural network and we have C in input channel and C out output channel, and kernel size, for example, is 4, so we will have a tensor like this figure. So weight standardization means that we standardize these tensor before applying to the data. The technique that paper is talking about is a combination of channel normalization and batch normalization in the regime that we don't have enough data in one specific batch. So one may ask that, is batch channel normalization redundant? Because we already applied channel normalization on data, and again, we are applying batch normalization. But the answer is no. Channel normalization needs batch knowledge to keep the models away from elimination singularities. At the same time, it also brings benefit to the batch-based normalization. Batch channel normalization runs in both large batch and also micro batch setting. Batch normalization is linear, but channel-based normalization is not linear because it changes based on the data, because it normalizes each sample individually. Therefore, they are adding a strong nonlinearity and increase the model capacity. There is a point here that when we apply batch normalization on training, we just save some statistics and use those statistics in test time. But when we do channel normalization, we are not saving any statistics because instance can change in inference time. Therefore, channel normalization will be more robust to statistical change and show better generalization for unseen data. In the paper, they are showing different results. I don't want to go through all of them, but just want to highlight the segmentation, instance segmentation, and object detection performance. They showed the combination of batch channel normalization and weight standardization can outperform the group normalization and only weight standardization. And in some cases, it can outperform just using batch normalization. Of course, having batch normalization with high number of sample in one batch is still a better option. But in many scenarios, especially in computer vision that we have high resolution images, combining weight standardization and batch channel normalization can beat the performance of batch normalization. I hope you enjoyed the video. Thank you. Share the video with your friends, put a comment, and subscribe. Thank you.